Anybody want to take a whack at what the difference between a VFD and an inverter is?
Well, an inverter driver versus a VFD, the whole machine is taking a whole lot more inputs and calculating all that into the actual speed of the compressor.
Yeah,
It has to go into auxiliary heat and electric
yeah,
heat be on before it's going to stay in and satisfy.
right. But basically, it's giving you multiple options for the heat pump to do its job.
Welcome to Talking Comfort Live, a show that reminds us just how cool HVAC can be by discussing today's hot topics in home comfort, from learning to laughing and sharing personal experiences to challenging the leading industry narratives. Our show goes deep inside the world of mini splits, heat pumps, and the inverter technology that brings efficient comfort to our products. And you can help us in our quest to make HVAC cool. We're looking for you to be a part of the show. If you have a question, whether it centers around application, installation, preventative maintenance, a future technology, or anything we share on the show, send it our way. We might take it live. Now grab a bucket and take a break. It's time for Talking Comfort Live.
Good afternoon, everyone. I'm James McIntyre, the Senior Director of Commercial Sales. We're going to go down the line and have everyone introduce themselves. We'll start with Greg.
Hello, everyone. I'm Greg Bruntz. I am the technical support specialist for mini VRF and VRF products on the commercial team, along with whatever else James decides to throw at me.
And now we have Jesus.
Good afternoon, everybody. My name is Jesus Fraga. I'm the inside sales engineer for VRF equipment. And as Greg said, anything else that James wants to throw at us?
And we have JD.
Hi, I'm head of tech support training, and also I do tech support as well and take calls that come in.
Good to have you, JD.
Yeah, thank you.
All right. Well, first, we'd like to hear from you. It's what makes the episode good every single time is your comments and questions. If you're on a job site and you have a question, please feel free to call the tech line. Otherwise, if you're watching this, submit questions anytime using the question mark icon to the right of your screen. Like I said, please ask questions. Well, we do have a very, very packed show today. We're going to be covering a lot of stuff. So, pay attention. And as always, these episodes are recorded. And in the link for the description, if you are watching this and it is recorded, you can skip right to the things that you want to listen to or learn. We're going to cover what's the right set point for a thermostat or wired controller or wireless controller for that matter. We're going to have a quick lesson on the science behind a hot second floor. We're going to be comparing the GMV and FLEXX controllers and their behavior. And then we're going to talk about what really controls airflow. Last but not least, we're going to talk about oversizing indoor units when installing multi-zone and MultiPRO systems. All right, and we'll be checking throughout the show for questions and comments. Again, one last time, click that question mark icon to the right of the screen and submit your questions or comments. So let's go ahead and start talking comfort. All right. So for our first segment, what is the right set point for the thermostat? Let's talk about that. Greg, what's the temperature that you should be setting on your thermostat?
That's always an argument in my house. My wife says it's way too cold, and I say it's too hot. So, I used to, at the house I lived in before, around 74. Every climate's different, every area is different. So I moved away and got a different home, and I just found like 72, 73 is like the ideal temperature zone I want to be in. My wife hollers at me all the time, it's way too cold. So, and that goes back into my service days. I can remember doing service calls and literally having the white husband and wife arguing about what temperature they wanted the program set when I'm trying to help them program the thermostat. And I'm like, if you guys can't decide which temperature it's going to be, I don't know how you want me to help you program this thing. So it's never going to be a one temperature fits all kind of thing, right? So
Right.
what do you guys say, Jesus?
Yeah, no, that's true. I still remember having those conversations with homeowners, and they ask me all the time, "What temperature do you recommend?" I was like, "Well, it really depends on y'all. Just start out at a X temperature and just adjust as needed." Because to say this particular person is comfortable at 74, is wrong because you just don't know unless they actually tell you that. So it just
Right.
depends. A lot of other factors come into mind too. So like if, for instance, if you're trading out, doing a change out on the system and they go to wall mounts, well, they're probably going to feel a little bit colder than what they're used to, especially if they're pulling out a ducted unit, and like I said, installing a wall mount. They're going to feel that wall mount, put out some pretty good air, cold air coming out just because they're a lot more efficient as far as like there's no heat loss or cooling loss there.
Through the ductwork. You don't have
Right,
ductwork.
yeah, exactly. Yeah, through the duct.
Yeah. JD?
Yeah, I set mine for 71 at night, and then during the day I have it go up to 74. So
Wow,
kind of,
big temperature swing.
yeah,
Yeah.
but that's good. It's not a huge one, but it's more for comfort at night, and then really 74 is kind of a good temperature. Just leave that all day, but
So I do have a piece of advice for all HVAC guys out there that have systems on their own home and in the same scenario that I'm in. What you do is you put up a controller that your wife absolutely hates messing with, and then you get Wi-Fi control, and then make sure that her password doesn't work. And when she asks you about it, say, I gotta look into it. So she literally hates messing with it, so she don't mess with it. She gives up on the conversation, and then I get the temperature wherever I want it.
smooth move.
Yeah. Well, I think as it applies to our equipment, it's something that we get confronted with from time to time. If you're taking out a standard system with a constant speed compressor, that kind of thing, replacing it with an inverter-driven system, it's going to have longer run cycles. It's going to dehumidify more so than unless conditions are just right, it's going to dehumidify better than a lot of other systems out there. And with that, if it is lower humidity, you do have the tendency to feel cooler, right? So,
Or as you get older, you get colder.
or as you get older, you get colder, sure. But a set point of 72 for a standard excuse me, a standard single speed compressor based system, setting it at 72, you might have higher humidity. And so 72 feels very comfortable, but with the longer run cycles of an inverter driven system, you may end up with a significantly lower humidity, and then therefore the customer might say, hey, I set this for 72 and I'm freezing in here. What's wrong with the thermostat? And that happens, we get to talk about that a lot, actually. So I think that's something
Jim,
to keep in mind. I mean, what I like to say is if you're cold, turn it up. If you're hot, turn it down. It's like
I
a
think you're
specific
on to
temperature.
something.
It's not a.
I think you're on something there too, because I had an inverter system at my old house, but it was a ducted inverter system versus what I have now is both a combination of ducted and non-ducted.
Yeah.
And I really do think the humidity is much lower than it was in the other house, and that's probably why my wife thinks it's much colder than it was. But again, the climate outside is different, so. And I guess that's why it feels hotter to me. I could say I go outside for a little bit and I come in and I just want to cool off and anyway, I'm chilly and I like it that way.
Well,
Chilly and don't like it that way. Put it that way.
right. Well, talking about that outside condition, particularly like across the southeast or like further down, like Florida or something like that, where you do have a higher humidity environment. Typically, when the humidity is as high as it can possibly be, right? It's overcast, it's cloudy, it's raining, it's whatever. Well, from a load standpoint, from a sensible load standpoint, your unit doesn't have that. So at that moment, for a system that was rated at 95 degrees, right? It's not 95, so now it's oversized. That's the way it is. That's the way it always is, right? If
The
it can't
equipment's not
slow
running
down,
enough to pull
yeah.
the humidity out. Yep.
So we're not going to run long enough. We're not going to have the opportunity to pull the humidity out. We got a 3-ton unit. I basically get 36,000 BTUs for a short period of time, and then I'm right back off again. There's only so much you could do from a latent heat removal aspect in a situation like that. So you end up, yes, in that regard, not only is it higher humidity outside, but it's going to be higher humidity inside. That's just the way it works, right? But if you have an inverter driven system, you're able to slow down, you're going to draw more humidity out, and it's going to be drier. And that's absolutely something I've noticed, with my system as well. Even the inverter driven system that you had, Greg, I mean, I believe, depending on which model you had, it may have been a 5-speed or a
It was
4+1,
5-speed.
or
It
yeah,
was
it's
a
5-speed. So
Yeah,
I
it
mean,
wasn't
that's
a
fine.
true. It wasn't a true fully variable inverter system.
Right. So if you needed 68% of your cooling, it was providing 75, right?
Correct.
Something like that. But the system that you've got now, if you need 68, you get roughly 68, it may not sound like a big difference, but the longer it can run, the better dehumidification you're going to have. But yeah, so if you wanted to know, 74 in my office, we have the opposite problem. My wife is always hot. You know what I mean? She's always hot. But anyway, and I'm the one that freezes to death now. Wouldn't expect that with the R value I got going on. But all right. Well, let's just talk a little bit more in depth as far as a little bit more in depth on temperature control. So the next segment we're going to be talking about is it hot upstairs? Blame science and maybe your ductwork. Here we got a diagram that we're showing. It's 82 degrees on the second floor, 75 degrees on the first floor. All right. Obviously, warm air holds more moisture and rises, right? Well, it definitely rises, right? So it can feel much hotter upstairs, that kind of thing. So you're adding to the load upstairs. It's also closer to the attic, right? So if you're on a half floor type construction, like that half story type construction, not only is the roof right above you, but that attic space is also on one of your walls or two of your walls, right? Now, what can you do to mitigate that, right? What can you do to mitigate having 82 degrees and 75, 82 upstairs and 75 downstairs?
Well, I just want to comment. I mean, when I was in the field in the area where I ran service in Missouri, it was huge back in that era. The majority of two-story homes that were single on-off, bang on, bang off systems. In other words, single stage. The number of two-story homes with one system was enormous. More two-story homes only had one system. So yeah, you get the first floor comfortable. The upstairs was never comfortable, not in summertime, and then the exact opposite in the wintertime. The first floor was burning up to try to, the first floor was cold, but the second floor was burning up because you're trying to get the first floor to temperature because your heat rises. So the first thing I say is, and I said it back then, I'll say it today, and I was more involved in traditional systems back then. The only way you're going to mitigate that is two systems.
Right.
Which the industry's gotten much better now, where you have just a ton of different options. You can have one outdoor unit like we do with MultiPRO and have two air handlers inside, one for the upstairs, one for the down. You can have, say it's existing home, you don't have good ductwork going up there, you can do a MultiPRO system on the first floor and add wall mounts on the second floor, or a couple cassettes or whatever. You could not do anything with the first floor and just do a single zone or multi-zone mini splits on the second floor. I mean, the options are endless, but what, in my opinion, and Jesus, you just came from the field, a lot of times they tried damper systems and stuff like that. I still found that wasn't totally adequate in doing zoning to try and get that second floor comfortable. You still got one unit that's trying to do all that cooling. Your loads are completely different.
Yeah, no, that's true. Like I was saying, I still remember pulling up to the house and, their system's down or whatever, and, you finally get it up and running. This area over here, it happens to be the first floor. I think I lost you guys. Can you guys hear me? Okay.
Yep,
So,
you're back.
Yeah, you're back.
so I was saying, I still remember going to a customer's house and they're like, this side over here, typically is always hot or always warm. And then you go into the crawl space, if they even have one, and you're looking at 40, 50 feet of one duct just going over there to try and cool down the space. And it's just like, there's just no way. Then we really gotta, choose our equipment wisely, and especially with the selections that are out there, with MultiPRO and, really separating that system. That way we can get that balanced point of cooling the first floor and the top floor, efficiently.
Right. Right. So
JD, anything to add? Just
No, I mean, you guys are kind of hitting nail on the head there. Like a lot of times when I was in the field and ran into that, of course, I would just tell them, kick the fan on and circulate that fan, just to keep that upstairs even with the downstairs. And a lot of customers were like, "Oh, that solved it," but of course, you're running that fan all the time and costing yourself energy there. But
well,
yeah.
I mean that helps, but yeah, you're right. It's not going to solve it completely.
I mean,
No.
just to nerd out a little bit, one of the reasons why I don't really care too much for the damper system in that regard is that, if I've got a 5-ton unit, I'm just distributing less air at this point. I'm taking a 5-ton unit. Still got a 5-ton unit. So while it's running, I'm taking, half that CFM or 40% of that CFM or 40% of that capacity and dumping it somewhere, right? And but I'm still running a 5-ton unit. So I mean, yeah, you can get better comfort, maybe. If it's all set up right and all that kind of stuff, right? But is it going to save? Is it going to save money?
Right.
Right.
I think all of us on the kind of hosting this conference or this webinar are all in agreement that the best way to really zone, completely one home, one business, whatever, completely different loads in a building or a home or whatever. The best way to do it is zoning by refrigerant flow with a unit that can modulate to the load. Which is exactly what an inverter system does. You have multiple indoor units. You have an outdoor unit that can modulate to the load, and the refrigerant flow only going to the heads that really need that are under the high load.
Any other way, you're just wasting a bunch of energy.
Yeah, I mean, from a comfort standpoint, from a deliverable standpoint, it's like having 2 systems. But from a cost standpoint, it is almost always less expensive than 2 whole systems. Like from a total installation standpoint, it is.
So it'd definitely be cheaper than 2 whole systems.
Yeah,
I agree with that.
Yeah, well, and also don't forget that if you got 2 systems, you're also talking about 2 wire, 2 disconnects, 2 everything, right?
Yep.
I mean, it's not just an equipment cost thing.
And for contractors out there, they come up to a customer's home that has a one system on a 2-story home, for example. And, there's a lot of this goes on throughout the country, so husband and wife's living in the house and the kids have grown up and gone. Majority of all they really have is their master bedroom up there, which is the only room they use. They don't even really use the other bedrooms. But they still have this complaint of the upstairs being hot and the downstairs being cold and so on. I mean, in situations like that, the best answer to that may be just adding one single zone mini split for the master bedroom. So when they go to bed at night, they're comfortable. They don't really need to do anything with the rest of the house because they're not doing anything. They're not using it anyway. But now if you got a 2-story home like that, that's still got a full family living in it, then you might want to look at something else. There's a ton of different options is all I'm trying to get at without having to break the homeowner's bank.
Yeah. Yeah, I mean, that's always something to talk about. I know that, from a new construction standpoint, we all know, they won't pay for it. Whoever they is won't pay for it. And we all know who that is. We have sold a whole lot. I mean, an amazing amount of multi-pro systems and like more semi-custom or custom homes. Those kinds of those installations. I mean, but it's not going to work for everybody. I mean, it's just not going to. If they really just want to look at what your equipment cost is, ignoring your labor, ignoring the electrical, ignoring the pads, ignoring the disconnects, all that stuff, right? It's kind of hard to make that argument. It can be, and I totally get it, But if customers have a choice, I mean, it's up to you whether or not they have an opinion on it, right?
Right.
If customers have a choice, give them the options,
Exactly.
But Let's see.
I mean, I can go years ago. I'll give another example. I've some friends of mine were building a home for their grandson. These were people that had money, right? And it was a 2-story home, and they were going to put one system on it. And I said, absolutely not. You need to do 2 systems. And this is before inverters really got big, right? And he's like, no, 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 it's going to cost too much to run the equipment and everything else, and more to install it. I'm like, I don't know. You need to do your homework on that. I said, because, and I explained, in the summertime, the upstairs unit is going to do most of the running. Downstairs unit is not going to run as much, and vice versa. In the wintertime, I don't think your utilities are going to be as bad as you think. I said, cost-wise of installation, I says, now you're doing 2 systems with smaller ductwork rather than one large system with bigger ductwork. I said, you got a little more electrical work because you got 2 circuits and stuff like that. I get all that. I says, but when you really lay it all out, and they ended up building the house. And when I went the first time I seen the house, I went down, I'm like, oh, you decided to go with 2 systems. He goes, yeah, the cost difference to do the 2 systems was really not all that different. And I don't remember exact numbers. He says, but it was more than affordable to go, to change it up and go to 2 systems. And now that they had been in there a while and seen the utility, he goes, man, you're absolutely right. That's exactly what's happening. The one system, the second floor runs mostly in the summertime, and the first floor runs most of the time in the wintertime. And he goes, and the utilities are definitely reasonable for that size home. It was a good size 2-story house. So, just because you got to do, doing 2 systems doesn't necessarily mean it's going to be that much more expensive than, because the way I explained it to them, I was like, okay, so if you got 5-ton load, what's the difference of having two 2.5 tons versus 1 5-ton? I said, your total electrical draw on 2.5s is probably less than the 5.
Yeah.
And I wasn't looking up the numbers. It just made sense, right?
Probably. Yeah. Right.
So, but no, they were tickled pink that they did it, and they were glad I had the conversation with them. And I didn't have anything to do with it. I didn't install it and sell the system. I didn't do anything with it.
Right. Well, on that single system, doing 2 stories, I mean, where that one return goes, I mean, maybe you split it up and go to 2, but I know right now you can still go through a lot of houses and they got the return in that, I don't know, the staircase, like where the stairwell is. They try to pick a good middle spot for it, but you also don't want your thermostat on the stairs, so you try to put it somewhere that it might get some kind of central, distribution of air. I mean, it can be pretty difficult. And the fact is, like, if you can help to prevent some callbacks and stuff too, I mean.
Well, in the Midwest, they used a lot of the returns were done in the wall cavities. And I could be wrong on this. Don't quote me on it. But I think they're starting to steer back away from that and making you go to sealed returns. Because you can get air leakage like from the attic and stuff into it if it's not sealed properly when you're using the walls return, or air leakage from a crawl space or a basement. It affects the return. When you have an enclosed duct for the return, you eliminate them. And I actually was involved in a situation where they didn't seal the top plates right, and they had major mold. In fact, there was 2 houses up in the Missouri area that had to be completely dozed, the brand new homes, because of that air leakage. It created mold problems in the home. And once you get that mold set into the house like that, there was no salvaging it. They had to literally knock the house down and rebuild.
That's terrible.
Careful. I only share experiences like that for guys that are out there doing this work every day. And, be careful of what you're doing, because, it could come haunt you if you're not doing it right too.
Yeah.
Right.
So,
all right. Well, let's take a look at some questions. I mean, I think that was a good segment. A lot of good information there.
Yeah, we got a couple that came in. Looks like this one's a comment. Lance is saying, just installed the MultiPRO system with 2 3-ton fan coils as an end user now, and it took some time getting used to the continuous fan. My comfort tip is now lower during my program times, and the electric bill is way lower. So, just another example of what the MultiPRO system can do for you, and versus traditional, unitary split systems.
hey, Sus, I'm not looking at the questions. I think you made that up.
No. Mhm.
No, in fact, he said the electric bill is way, way lower.
Yep.
So he said way twice.
I was just kidding. I hadn't looked at them, but
Appreciate it,
no,
Lance. I had the same
I
experience.
totally believe him
Yeah.
when he's saying that. So
Well, I mean, 3 out of 4 of us have a multi-pro system on our house. One of these days, one of these days, JD. One of
Yep.
these days. Yeah.
It's gonna happen.
It's gonna happen. Yeah. I mean, our boss has one too. So actually 2 of them, right? She's got 2 on her house, right?
Yeah.
Yeah. Right.
So, James, I know I kind of wanted this, this is still laying around in my head, but I kind of just wanted to add this for the contractors that are, listening in. So don't be scared, to talk to the homeowners and, present them with the options, because honestly, that's the way that, you're going to blow up your business. Because if you're not presenting options, there's no way that they're going to choose, a higher end system if you're not there presenting it to them the correct way as well. So.
Right. Yeah. I mean, not many people want to go look through 1,000 hours worth of YouTube videos to go find out what would be the best thing for their house and that kind of thing, and then request it. And then on top of that, from the contractor standpoint, if you're quoting regular stuff every time, that means that everybody else that's quoting regular stuff is your competition. That's who you're competing with every single time. And then it's down to, I've been in business longer, or the price of it, or whatever. I mean, if everybody's quoting the same thing, right?
Right, exactly.
I mean, it can at least be some product differentiation. You're giving them the option. You're helping them to make an informed decision, and at least in my experience, often they value that regardless of what system they pick. Whichever they choose, because it's not an inexpensive decision, is it? It's not.
Nope.
It's a very important one, and it likely will be the last time they have to make that decision at that house, or it's going to be a long time before they have to make that decision again. So they got to buy something, they got to stick with it. Chances are they're going to be sticking with it for longer than they would stick with a car or an appliance or something like that, right? All right, let's see here. Oof. Do we have any more questions that we want to get into at the moment? I think we're going to hold off on one of these until toward the end.
Yep.
All right. All right, let's get to our next segment. This is going to be comparing the GMV or MultiPRO and FLEXX controllers and their behavior. All right, so let's take a look at some of the differences here. We've got the WK010 WC1 that can be used in the FLEXX Ultra and FLEXX Eco, the FXE and FXU R32 systems. Again, that's the WK010 WC1. And we're going to compare that with what we use with our MultiPRO and VRF systems, the XC7C23H. All right. So one of the first things that I would like to point out is, if since MultiPRO is capable of multiple zones, you're going to be able to control up to 16 individual heads off of one controller. With the FLEXX, it's not capable of multiple zones, so you're going to control one system. But let's see here. As far as some of the high points go between these controllers, I mean, they're both wired communicating controllers. So with the WK, that's going to have built-in Wi-Fi. With the XC7C, every individual controller is not going to have Wi-Fi built into it. So we've got one inexpensive solution for that, which is a G Cloud, which can also control up to 16 units. But with a MultiPRO system, the maximum amount of indoor units you can connect to is 10. But you'll be able to add all 10 units all at once pretty quickly through the G Cloud app.
well, and let's
Yeah.
James, let's be a little more clear with that.
Okay.
Because when you got more than one indoor unit, it's a system. You want system control, all the indoor units. And you can't do that just off of one wired controller, because if one wired controller is hooked up and only controlling one head, you're not controlling the system. That's why you need the G Cloud. So it's going to plug up to one of the indoor units. Doesn't matter which one. And now you got control of the entire system, all the indoor units on that system, because it is a communicating system. And that's why you would need the G Cloud. But the controller itself also has to be Wi-Fi compatible if you want G Cloud to be able to pick it up, and the XC7C-23H is capable of doing it.
Gotcha. Okay. And if for units that you're not going to be doing wired controllers on that MultiPRO, like with the wall mount units, let's say you just want to use the handheld, you can still control that from your phone without having to add a wired controller to do that. Next, we have the communication protocol. I think you probably had something to add on that. That is RS485 on the FLEXX wired controller and HBS on the XC7C.
Yeah, I do want to add into that. So the RS485 is a communication protocol. The only difference really between that and the HBS in the MultiPRO is you have to have 24-volt power as well. So to do RS485 with FLEXX, you have to hook up H1, H2, and the 24 volts. For the controller on the MultiPRO, you're only hooking up H1 and H2. It's powered through the H1 and H2.
Gotcha.
And the other thing, I was talking to JD about this just the other day. I think it's best for you guys when you're out there doing a FLEXX system and your H1, H2 now has to make the whole system communication. So you got to have H1, H2 from the outdoor unit to the indoor unit, and also from there to the controller. And it's like a daisy chain pattern. But if you don't hook up the H1 and H2, it's not fully communicating. So that thermostat, and that's why I also have on there 24 volt in the further part of it, that thermostat is capable of being a 24 volt regular thermostat, or it's capable of being fully communicating thermostat. Depends on which way you'd like to utilize that controller on the FLEXX system. And that controller is unique to only the FLEXX system, as far as we know right now. The reason why I say that you're better off to run a separate cable for the 24 volts versus the RS485 is because if you inadvertently hook up the wrong wires and put 24 volts into the H1, H2 circuit, you're going to fry boards. So if you have a separate cable, you're less likely to make that mistake, or if the wire gets damaged and it actually shorts into the H1, H2 circuit. So you guys, I'm telling you, you can do it. You can do it all in one 18-8 cable. I've done it in the lab down in Atlanta, but out in the field, you might be asking for trouble if you're doing that unless you're really careful about what you're doing, and be careful of getting damaged cable.
Have you seen this have you seen a system like that where they did
absolutely.
share? Okay.
Absolutely, yes.
Gotcha.
And once you do that, then trying to figure out what all fried is not fun, because it's not like
it could fry outdoor boards, indoor boards.
Correct. And you can look at it, you can look at that board all day long, and you're not going to see a burn mark to say, okay, it definitely got this board. It's going to be a trial and error type of thing. There's no good way to troubleshoot that either, other than the fact that you don't recognize that unit with the controller. You get communication code, but you don't know if you fried anything else in there.
Gotcha.
Luckily, with the FLEXX system, you don't have a lot of boards anyway. You got one main outdoor board, you got one main indoor board. So it's probably just going to be both boards. But I hate for you to, on a new system, have to go doing that.
Right.
Just because we made a mistake hooking up the wires. And it's easily done. I'm not trying to say you guys are going to make that mistake. I am capable of making that mistake. I've made those type of mistakes when I was in the field. We're all human. We make mistakes. We learn from mistakes. We move on. It's not like that. I'm just trying to help you guys avoid that scenario.
Right. Okay. Yeah, that's a good point. And like you said, if you've ever dealt with a 24 volt short, if you haven't, welcome to HVAC.
No kidding.
Congratulations on your first year. But if you've never run into that before, well, 24 volt short is difficult enough as it is, without it also, affecting printed circuit boards. All right. Next, we got programmability. They're both 7-day programmable. Error code display. With a fully communicating system, you're going to have error codes that will appear on the wired controller. So if you've got on the FLEXX, if you've got your H1, H2 connected and you're using this wired controller, if you've got a fully communicating system, you'll see the error codes be displayed on the controller. You don't have to wait for it to get hot in the house before the customer calls and says, "Hey, I need somebody out here immediately." They can have an error code. Maybe they reset power and they can run for a little while until you get there. That's one of the benefits of using an inverter-driven system. But both will show those error codes. If you are not using that wired controller, or if you are not using, if you're just using strictly 24-volt control, it will give you error codes, but those error codes will display on the outdoor or indoor unit, like on the boards themselves. So, it would take you guys taking the panels off to go see what that is.
Well, the controller would still be able to give you the error code, like as if it provided you hook up the L terminal, like as if it was into mitigation alarm, stuff like that. They give you some of the error codes. It's going to be limited though.
Right.
You don't have,
yeah.
It can't give me any outdoor error codes because it's not communicating to the outdoor unit. And you're going to get limited error codes from the indoor unit in the 24-volt setup.
Yeah, I got what you're saying. So running the outdoor and indoor on 24 volts, but using the wired controller. Okay.
And then also, we haven't launched it yet, but once it comes, we are going to have the service tool for the GREE FLEXX R32 units. But if you don't have H1, H2 hooked up, then you can't see the whole system. You're only going to you got to plug in for both. You can plug in the indoor unit, see that unit, and you can plug into the outdoor unit and see that unit. But if you have H1, H2 wired, whether you're using 24 volt or not, you can have H1 and H2 wired between the two units and still be able to use the service tool, but control it by 24 volts. It's just whether or not you're hooking up H1 and H2 to the controller to use RS-485 to control the unit. So you don't have to. You can use 24 volt. And you don't have to use GREE's 24 volt thermostat. You can use anybody's 24 volt thermostat. So I'm gonna make sure I get that clear too. We're not saying you have to use this thermostat.
Right. So like retrofit applications, maybe you don't have the extra wires, that kind of thing. It still gives you the same great flex that you've always been installing. Or if you haven't, it gives you the same flex that everybody else has already been installing.
Yep.
But yeah, for the fully communicating, it's got the capability of it. If you want the full capability of the unit, that's what you'd have to use for the full capability, if you want absolute phenomenal dehumidification, that kind of thing, that's what you'll do. But let's see, what else? Parameter settings, like as far as the settings and being able to configure the system for your application. It says we've got full project and parameter settings for both systems. I don't have any experience taking a look at the project and parameter settings on the FLEXX, but I definitely do on the MultiPRO. Can you tell me, Greg, what those differences might be?
So it's almost the same in a sense. There is more parameters and settings with MultiPRO, obviously, because we also use that with our VRF line.
Mm-hmm.
But the project settings are more for almost like contractor setup settings. Okay? Yeah. And then your parameter settings is more homeowner settings that they can set. So it's no different. And the way I explain it is if most of your thermostats anymore, you can use them for heat pump. You can use them for cooling only. You can use them with electric furnace. You can use them with dual fuel. You can use them with, it's just like that. You got to go in there and tell that controller what it's supposed to do.
Yeah. And
both controllers are capable of doing that. But some of those project settings are settings you really don't want that somebody that's not HVAC, doesn't have the HVAC knowledge, messing with those settings because they don't even know what they're setting.
Yeah.
So it's like
we've never had that, right?
Never. Even when they're not supposed to get into it, they get into it.
Luckily, you can. There's a pretty quick way to return to default settings. I know on the XC7C there is. I don't know on the FLEXX. Do you know?
You can do it on both. You can do a factory reset to that controller as well.
Right. So if you suspect somebody messed with a bunch of stuff and they were able to, then you can reset it back to the way it's supposed to be pretty quickly.
But just as a reminder to everybody, on September 10th or 11th, I don't remember which date, one of them we're going to be showcasing the new MultiPRO R32. The other date is when JD and I are going to get back in front of that R32 R32 FLEXX system that we have set up in the lab. with the live broadcast, we're getting one of these production controllers. We had a prototype before, and we're going to go through that controller in depth live on one of those 2 dates. I can't remember.
Yep. So on September 10th at 11 a.m. Eastern, it's the FLEXX R32 setup, controls, installation, and troubleshooting.
Okay, there we
And
go.
on September 11th at 11 a.m. Eastern is MultiPRO R32 updates, alarms, and components.
Yep.
So be sure to go ahead and register for that so you can check that out when we do it, or you can watch it at your leisure at a later date.
Yep.
Let's go back to the
there's a few more on there. So
yeah, we'll go back to the features real quick. Yeah.
About the auxiliary heat,
There we go.
emergency heat, stuff like that. I mean, okay, so auxiliary heat, emergency heat, it depends on which controller, but auxiliary heat, emergency heat kind of mean the same thing, right? But in operation, auxiliary heat means a different thing. So I like to always explain that.
Yeah.
So when you're using a quote unquote emergency heat, that means the heat pump's not functional. You're only using the electric heat. You still have the ability to use the electric heat if the heat pump's not functional. FLEXX and MultiPRO are both capable of doing that. Now, on the FLEXX R32, if it is in a mitigation alarm, electric heat doesn't work, right, JD?
Yep, that's correct.
And I believe MultiPRO will be the same way because they do not want that machine running, if at all, electric heat or heat pump, if it's in mitigation alarm. Once the alarm clears, then the electric heat can work again. Okay.
Yeah, it is the same way on MultiPRO.
So on auxiliary heat, that means the heat pump's running for whatever reason, it's not keeping up. Maybe you don't have enough BTUs for that cold temperature. Maybe it's low on refrigerant. Maybe it's just extremely colder than what it was ever planned for that to be.
Maybe the owner turned up the thermostat when they came in.
Yeah, whatever.
Yeah, right.
Auxiliary heat means the heat pump's running, electric heat's running along with it. So both are running. And then that's where your aux differential comes into play. You can set that from 0 to 10 degrees. First stage of heating is going to be your heat pump. Your electric heat coming on is going to be dependent upon that differential. If you have a 0 degree differential, that means every time the heat pump comes on, so is the electric heat. If you have a 2 degree differential, you have to fall 2 degrees below set point before the auxiliary heat can kick on. But then that also brings you into the auxiliary heat timer. That timer on FLEXX control, you can set from 0 to 120 minutes. So even if you have a call for auxiliary heat, if you have that set for 120 minutes, that means it has to have the auxiliary heat call for 120 minutes before the electric heat's going to be allowed to go on.
Seconds? Is it seconds, Greg?
Oh, it's minutes in the control.
Okay.
From what I've seen, but
yeah,
I can't imagine them doing it in seconds. That's what I see in the manual. We're gonna relook at this when we're down in Atlanta.
Well, I mean, I know the aux heat timer for MultiPRO is definitely minutes.
Definitely minutes on the aux heat for the MultiPRO. It's 0 to 60 minutes. So regardless of what your differential is, if you give that a auxiliary heat timer, it's got to lapse that timer. So, and I've had people ask me, why would you want to do that? Well, to back to James's example, they had it turned way too low and they crank it way up. Let's force that heat pump to catch it up rather than bring on the electric heat. It's going to force that heat pump to do all the work if possible.
Yeah. And that's something we've run into from time to time, especially in areas that aren't as accustomed to using heat pumps, especially in the dead of winter. They're still doing setbacks because the only way to save money, at least used to, was to keep your equipment off.
Yes and no, James, because I mean, I've had, put it this way, I like it cold when I'm sleeping, but I like it warm when I'm awake. So when it comes out of setback, I want to bring it back up to what my temperature would be when I'm, and I'm talking, I like it like 64 degrees when I'm sleeping, and like 70 when I'm awake in the wintertime. I mean, that's a 6-degree demand. So if it comes out of setback, that thing's going to go cranking electric heat unless I set that timer. So I can tell you right now, guys, at my house, mine's set at 60 minutes. I don't want that electric heat coming on unless it's been at least 60 minutes.
Right. The big downside to that is that, I mean, you're talking about a high efficiency system. The customer's buying a high efficiency system. They are planning on saving money on their energy bill, but their habits can offset whatever savings they may have had. You know, if they're spending, you know, an hour or two using electric heat trying to catch up from the abnormally low set point that they set while they weren't at home or when they're
Yep.
asleep, for example, then they're using electric heat like I'm sorry, they're using their full heat kit and also their heat pump at the same time trying to catch up. So I mean,
Well, real,
you could eliminate a lot of the savings that you could have saved if you put this, you know, if you go ahead and set it for a little bit longer for the aux heat.
but James, realistically, I'm doing that to myself, even though I'm holding out electric heat. Because if I kept that at that 7-degree set point all night, I probably would spend less hours running the machine running at higher hertz. It'd be running, if it ran, it'd be lower hertz. So my
Yeah.
total time and the hertz the compressor ran at versus the time and the hertz the compressor ran at coming out of gaining that six
Yeah.
degrees back. In other words, I'm probably costing myself more money if I really did all the
Well,
math of that.
Yeah, and the thing
Because
is,
I'm putting a huge demand on it. And that's not what these systems are designed to do. These systems are designed to maintain temperature, not
right.
put high demand on them.
Well, I mean, that's what I'm saying though. A lot of people always looked at it like the only way to save money is to keep it from coming on. And that's the reason why news reports, you know, every summer, every winter or whatever are telling you, hey, go set it your thermostat at 80 degrees. Everybody laughs about that. Nobody's going to do that. Right. But everybody does, you know, they always talk about doing that because that's the only way to save money with a traditional style system. That's the only way. Keep it from running as much. That's the only way to save money, right? Um, but I mean, that's definitely something to keep in mind if you're talking about selling a customer a high efficiency system. That, you know, there's some of those habits that probably just need to go away altogether. There was always an argument over whether setback while the space was unoccupied was a savings. There was always an argument on that, right?
Well, in cooling mode, it's never been a savings, well, unless
Well,
you're doing like a degree or two. If you're putting huge temperature differences, no, you're definitely not saving money. You're
there's
costing.
going to be some kind of crossover point. You know, if
Yep.
you're having to catch up 10 degrees and everything else in the house is 10 degrees and all that kind of stuff, yeah, it's going to take you a significant amount of run time to be able to make up for that. And at some point, it would have been cheaper just to maintain. Well, that was always an argument when you're talking with standard, you know, standard systems. Having seen the energy models and all that on set points for like VRF systems, for example, you know, for school systems, that kind of thing, they go, all right, we want it to turn off overnight, and then we're going to catch up at this, you know, at this time or whatever. And they would run all the math, run all the energy models and all that. And it got to the point where it would take, let's say, 2 hours to get to that morning set point. So the amount of energy was nil, whether they had it running a set point or maintaining. And in some cases, depending on what the, you know, the conditions were, it was actually costing them more money to have that setback with an inverter driven system than if they just had it maintained in the first place. So, I mean, if you
Right.
want to go set it back 1 or 2 degrees because it makes you feel like, you know, maybe it's better, go ahead and do that. It doesn't take much to catch up from 1 or 2 degrees. When we're talking about catching up, we're talking about having to run at a much higher speed. We're not talking about it running like it normally would at 60 hertz. You know, we're talking about 120 hertz for however long, you know, that kind of thing. So far and away more energy than what you would have just to maintain. But satisfied room temp is another one. That's, you know, that's an option that a lot of people like to have. A lot of people want to decide on that. Do you want to run your aux heat until you've caught all the way back up?
So now that but that needs a little more content.
Yeah.
It has to go into auxiliary heat, electric heat
Yeah.
be on before it's going to stay in and satisfy.
Right. But basically it's giving you multiple options for the heat pump to do its job. You know, I mean, if you're bringing on electric heat, well, at least at that point, you're basically running like you would anything else. This gives you the option, if you did have electric heat comes on, it gets within that aux differential, and then it turns back off and it allows the heat pump to catch up at that point, you know,
Right.
saving you a lot of money. But next we have operational data like parameter review. Like, you know, as a service technician, we like to be able to see that stuff. There's a lot of pressures and temperatures that you can see like that without even having to get your tool bag out. As always, we've had that available on MultiPRO as long as MultiPRO's been around.
And
You can go
I
get-
know pretty well what MultiPro shows.
Right.
JD and I will present that more in that broadcast of what kind of parameters we can see.
Is there a high pressure and a low pressure sensor on the FLEXX?
Yes, there is a low pressure and high pressure sensors on.
So there's
Used to only have one, and
Yeah.
it was reading high pressure and heating mode, low pressure and cooling mode on that pressure transducer, but now it has two.
Gotcha.
On the FLEXX R32, it has two.
That gives you a lot more information than what you would ever get out of a standard system. That's for
I just
sure.
don't know how well or how much is displayed on the controller. We'll mess around with that.
I understand. Now for the XE7C, we can speak to that because we went through the entire menu and reordered the menu and retranslated the menu and all that. So, Greg and I did that. We can speak to that a little bit more in depth as far as like the order and all that. It's exactly how you need it, exactly how it's displayed, a good explanation for each one of the, the data points that it's looking at. So just, we can speak to that at least. Just as a reminder, tune in September 10th. You'll see all those details, right? With you and JD, right, Greg?
That's right.
All right.
Looking forward to that, aren't we, JD?
Oh yeah.
Looks like we have still have some questions. Y'all want to cover them? We have questions and comments.
It depends on the question, man.
And hey, Seuss, you can go ahead and answer that question about the MultiPro 55. Go ahead and read the question.
Okay, so it says, hello, GREE team. Regarding the upcoming R32 55,000 BTU multi-zone system scheduled for production later this year, can you confirm the expected ship date or distribution date? And he's asking, where are the maximum allowable line set specifications, specifically the total combined piping length and the maximum equivalent length to the furthest indoor unit? Appreciate your insights.
The reason why I told you to go ahead and read that question is because it's a really simple answer. When we have that all information, it'll be on the website. We don't have it yet.
All right.
Yeah.
So moving along here.
Yeah. As soon as we have it, we'll put it on the website and get that information out there, and distributors and all that get email notifications for it.
And I want everybody to understand out there, when it comes to the production world like that, I've got a lot of experience with it. James has a lot of experience with it. A lot of that total final data is not available till right at production.
Yeah,
we struggle to get that information, don't we, James?
Yeah, the design, the tooling, the production line, all of that stuff is happening exactly at the same time. And then there's final testing and stuff like for HRI that has to occur. And so before they can actually start publishing the data, they of course have to have the HRI numbers to report as well. And then there's also the UL testing that's done through ETL or Intertech. It's a lot of information all at once that you end up having to sift through, and
so in their defense, they got to make sure things are right, and they're going to kick out the right data.
Right, because they include the manuals with the units. We can update stuff on the website every day, but somewhere they're going to have that manual, and it may have an error in it, and it's difficult to deal with.
Exactly.
Right. So moving along here. So this is just another comment regarding the wall cavities and using that for return air. Looks like Ryan got an answer for us. Says modern energy codes, probably IECC 2012 and later, don't permit using building wall cavities for airflow. Need sheet metal on all four sides or flex, etc. And that's kind of what we had said. And so thank you for your insights on that.
So I think specifically he was talking about what Greg was talking about, not being able to use
just the wall itself.
Wall mounted return. Even if it's housed in sheet metal, but some areas have gotten away from allowing the use of them being in a wall. Not necessarily using like the sheetrock or whatever to seal it, but just in a wall period. Man, am I speaking right here, Greg?
I'm not for sure on that one. I think they can still use the wall. It just has to be sealed
Right.
in the wall, like a sheet metal duct inside the wall. They can't just use the chase anymore. They can't use the drywall to act as the duct. Is what I think is a lot of municipalities, counties, and codes and stuff are making them get away from that.
Yeah. Well, that's absolutely the case. Yeah. Using the wood, like just encasing your floor joist, for example, or whatever. I don't, with the international codes and all that, yes, I'm sure, probably 2012 or later, but I mean, local codes have been addressing that for a long time, depending on where you live. Things like smoke spread or, fire spread and all that. There's there's a lot to take into consideration of being able to use them or not.
Right.
Okay.
All right. And so if you want to keep going on the questions or?
Yes, sir.
All right. So Craig commented, he said, can you adjust the temperature calibration on the GREE thermostats?
Okay, there is a offset in there. In other words, what he's asking, and you can correct me if I'm wrong, but like if I always use the example when I was out in the field that the homeowner got their $2 thermostat from Walgreens and they hang it next to the thermostat on the wall that they paid a couple $100 for or more. And they want to know why that thermostat isn't reading the same as that $2 thermostat that they bought at Walgreens.
Thermometer. Yes.
Thermometer. Yeah, I'm sorry.
Yeah.
So anyway, yes, there's offsets within the controller where you can get it to more closely read to their $2 thermometer. That's what he's asking.
Yeah. Well, or to get it closer to your fluke or field piece or whatever too. I mean, yeah, I mean, it could depend on, wall penetration. It could depend on a lot of things. But yeah, there are
Well, that's a big one, James. I'm glad you brought that up because a lot of people, I've seen it for years, where the hole behind the thermostat's not sealed and it gets infiltration from another space, making that thermostat think it's warmer or colder than it actually is, which is throwing off their set point.
Right. Yeah, the space being like attic or something, right? Something's real hot.
Right. Or even real cold.
Yep.
Yeah. I mean, one thing to keep in mind too is, is the why on that. If somebody, I mean, like what we were talking about before, if somebody says, hey, I was comfortable at 72 and now, I'm freezing my butt off in here or something like that. If you take a wall mount unit, there is an offset that's already programmed in it. A ceiling cassette also already has a programmed offset in it of a few degrees. And depending on the unit that you're using, like I know on the VRF MultiPRO side, those offsets can be eliminated, if they needed to be. I mean, but that is something to keep in mind because generally speaking, a high wall unit is supposed to be high on the wall. Ceiling cassette would be in the ceiling. Just like we used to talk about in tech support back when I used to do that, if somebody asks like, hey, what wired controller can I use on this unit? There very often there's a question as to why you're wanting the wired controller in the first place. And if you're thinking that it will offset a high wall unit that's mounted a foot off the floor, like it's already wrong, right? And there's been a lot of tech calls. I know that you guys still take tech calls just like that once you dig in a little bit further, you're like, oh, okay, well, it's a misapplication or it's a this or it's a that, like right off the bat, so you're trying to trick it into running longer or, whatever. But no, to answer the question, yeah, almost everything has that. On the MultiPRO side, the temperature calibration is a lot. So you got a lot of options there. Okay, I think it goes up to like 16 degrees Celsius, which is a huge amount. But and they have an offset for cooling and an offset for heating. So, if you only have that issue when it's cooling, you can just apply that offset there.
Right. All right. So moving on to the next one, Todd was asking, so do you have to connect the communication wires and the 24 volts to get it to operate? Can you just not connect the H1 and H2 everywhere and make the unit operate?
Yes. Yes, you can. Well, we're talking about the new Flex R32 unit, right?
Yes, that's correct. Yep.
Yes. Yeah, so we cannot run the H1, H2, but we would have to switch the dip switch on the outdoor and indoor unit, SA1, number one, to the on position, and then it would run as a 24 volt.
I believe Todd's asking if you have to have 24 volts for the unit to operate, whether you're using H1,
Oh,
H2.
Along with H1 and H2, right?
Yes, you have to run 24. You have to run RNC to the outdoor unit, and you have to run an H1 and H2. You have to have at least those 4 wire connections.
yes, but you did not have to have H1, H2.
No, he's talking about if you use hold on, I guess if you're using RS485, you have to run RNC to the outdoor unit and H1, H2 to the outdoor unit along with your controller. If you're using 24 volts, then you definitely have to run RNC out to the outdoor unit along
Right.
with your Y and your L and the rest of the other connections.
And that's from the controller to the air handler to the air handler to the condenser, right?
Correct.
Yep.
Yeah.
Okay.
Yeah,
Because
I
the way
think that's what he's aiming for. Is like, will it run if you only have H1, H2?
Okay.
if you have
Got-
H1
yeah.
and H2, yes, but you have to have the 24 volt to the outdoor unit and to the controller. Because as I said, the RS485 requires a separate power source.
So you have an RNC to the controller.
And
Yep.
H1
Have an
H2 to the controller, and you
Okay,
have to
and
run
then
the RNC to the outdoor unit along with
Okay.
H1 and H2 to the outdoor.
So it will not run on H1, H2 alone.
Correct.
No.
Okay. All right.
Sorry, I misunderstood how that was
No,
read.
it's all good. Well, I mean, I think we've got a lot of options out there, so it can be hard for everybody, including us, to keep up with it.
Yep. All right. Well, Todd, thank you for the question. Hopefully that answered it. Let's see. We got Robert. He's saying, is there an item number for the FXE and the FXU service tool or not yet?
I'm looking it up. I don't remember the number.
Gotcha.
All right.
So we'll come back to that, Rob.
Yeah, we will come back to that. So looks like Todd is asking another question. He says, is there a balance point setting on the thermostat to prevent the aux heat from kicking in? And I wonder if he's asking regarding the flex unit. Sounds like it is, right?
Yeah, probably.
Let's see. So I'm not really familiar with the flex controller. I'm not sure if that setting's in there or not.
I don't think it is. I'm looking here real quick.
Well, let's talk balance point. Let's get some detail on what we're talking about there.
Mhm.
And one of you guys fill it in. As far as balance point, what are we talking about there? For those of us who don't know. Okay.
Okay, I can do the balance point. I'm sorry. What?
Yeah, go
You
ahead,
want me to
please.
explain balance point?
Yeah, go ahead.
The balance point is basically like say, for example, you're doing dual fuel and you're running it on natural gas. The balance point temperature would be at what temperature is the gas furnace? Let's say it's an 80% gas furnace. At what temperature would the 80% gas outdoor temperature in heating mode? What temperature would the 80% gas furnace be more efficient to run than the heat pump?
Oh, okay. Yeah. So it's like an outdoor set point.
So what, in other words, if you were going to have a hard changeover in your controller to
Yeah.
say, let's say at 32 degrees, I don't want that heat pump to run anymore. I want the gas furnace to do all the heating because now that gas furnace has become more efficient than
Right.
running the heat
But I
pump.
mean, typically,
I'm
let's
not
say
saying at 32
historically,
degrees that's what it would be.
Yeah.
I'm just saying that given that is an example.
yeah, but I mean,
all of that plays a
traditionally,
role into the efficiency of the outdoor unit, the HSPF of the outdoor unit, the fuel you're using, the percentage of the efficiency of the furnace. I mean, that's a big old equation.
yeah, right. Well, I mean, historically, you would be using an outdoor thermostat in that regard, and then you would be adjusting your balance point based on an outdoor thermostat. I'm gonna go out on a limb here and say that this does not have that setting.
It does. In the
It does.
FLEXX controller, you can go in there and set a temperature where you want dual fuel to take over in a dual fuel application.
Yeah. Well, as far as what that temperature would be, yes, you're absolutely right. That's a ton of math involved in determining
And it
what
does
that's
have
going
the
to be.
capability of hooking up an outdoor temperature sensor. But if you're setting it all up on Wi-Fi, it can use the temperature through your Wi-Fi. You don't have to have the outdoor sensor. In other words, if it's 24-volt hookup, it can't use the outdoor temperature sensor built into the unit. You have to add an outdoor temperature sensor to the controller. It has an S1 and S2 connection.
Gotcha. But if you're using the H1H2,
If you're
which
using
is going
H1 and
out,
H2, then it can use the machine's outdoor ambient sensor.
gotcha.
Because
Okay.
now you're using a communicating step at that point. Or if you're using 24-volt and you've connected it to Wi-Fi, you can use the Wi-Fi temperature and you don't have to have an outdoor temperature sensor.
I gotcha. But to answer the question, we do have a balance point setting on the thermostat to prevent aux heat from kicking in.
You do.
Okay. Awesome.
All right. Yep. Looks like
That's
that was
good.
all the questions and comments.
All right. That's everything we got so far. Keep them coming, folks. Go ahead and use the question mark icon to the right of the screen to add your questions or comments. And we're going to move on to our next. Let's see here. All right, we're going to get deeper into airflow. Let's talk about what really controls airflow. All right, so we're looking at blower speed settings, that kind of thing. We're going to talk about our ductwork and, and how all of that can, improper airflow can affect the comfortability of the space. For example, if airflow is too high, you can limit the humidity removal in the space. Is that correct?
Yep.
Not really given a chance for that coil to get very cold, right? To be below dew point because you're hauling butt on your airflow. So, going and setting the maximum airflow and just, setting those dip switches and saying send it is not the way to go, right? Generally speaking, we're looking at about 350 CFM per ton, right? For good dehumidification.
Yeah. 350 would be a good number. 325 at your lowest.
Gotcha. Okay. And speaking of low, if the airflow is too low, whether that's from a set point, ductwork, dirty filter, dirty coil, what kind of problems can we have there?
Well, all sorts of problems, Dan. You're talking freezing, you're talking compressor discharge temperatures being too cold, where the refrigerant doesn't boil off in the coil. If you do run into that, you're talking a technician coming out to your house or business because more than likely the system, is down for some odd reason, right?
Right.
Yeah.
Absolutely. And
So,
as far as freezing, most of the time we're not really going to get too much of an opportunity to freeze because our systems have, freeze protection to prevent it from freezing, right? But yeah, we still see that even with an inverter driven system with all the bells and whistles that we're talking about, we still see, poor airflow pretty often. I mean, I would go out on a limb here and say that there's still a lot of ductwork out there that's not very great, from an airflow standpoint. Okay, well,
so James, you're saying if I don't get enough airflow in the back end of the house, I can't go into the controller and just bump up the static? Is that what you're saying?
yeah, I am saying that. I mean, as far as the hot and cold spots and all that, collars with dampers are not very expensive. Balancing the airflow in the space and providing the CFM that you need to provide or the capacity that you need to provide in the space in order to heat and cool it effectively. I mean, that's what we get paid for. We get paid for what we know, and that's what we know, right?
Right.
Having all your, having that bathroom dump out a bunch of air while the main bedroom's not keeping up. Going and bumping up the blower speed doesn't fix that. I mean, it does increase the airflow to the main bedroom, hopefully, but that bathroom is going to be like whistling, you know. And I know we see that a lot. If you've got a trunk line that runs down the middle of the house and the bathroom's in the middle of the house, we see that on almost every house we go to. I mean, those are pretty easy fixes, right? But yeah, take a picture. I mean, take your CFM into account. Take your static pressure into account. We've got a great video on how to hook up a manometer or a static pressure gauge, where to hook that up, how to measure it, how to set it. In fact, for the FLEXX system, we've got that on our website for like a quick reference to be able to set that up at your desired CFM. So, you know, we offer a lot of resources to be able to do that. So check that out.
And another thing to consider too on the FLEXX unit, they do have an oil return feature where if it was too low of airflow, high static, it could go into oil return, which, you know, it's doing that. It's going to ramp up to get the oil back. Homeowner may think it's going into defrost or something like that, but it's just, you know, to protect that compressor. And it can take up to 4 to 5 minutes. So you lose efficiency by, you know, the unit ramping up to get the oil back as well.
You will have excessive oil return cycles if you've got poor airflow on the indoor unit.
Yeah.
Among other problems.
Right.
So James, I want to just holler. I know Nick's listening to us. I put that product number up to answer Rob's question. As far as I know, I don't know if the programming is totally there yet for the R32 FLEXX. I did have the program. I've hooked that tool up, and I wasn't impressed with the display of it. So they're supposed to be working on improving that, and I haven't heard back yet. So part of the reason why we haven't ordered any of those service tools yet. Also, that service tool, once we do order them and get them in stock, that service tool is going to be capable of doing R32 FLEXX and multi.
Right. Gotcha. Well, I believe the product
Nick, if
number.
you could display the product number on the screen, please.
It's yep. So if you want to write it down, Rob, it's DE43, like Delta Echo 43-00/EF, and then in parentheses CM. And you know, who knows? Maybe we'll come up with a cool name for it or something instead of that model number. Way too many symbols and stuff in there, but that's a DE43-00/EF-CM. That's what that service tool will be.
And I do have the prototype of it. It's pretty cool. It's got separate plugins on it. One's for the GMV and the other one would be for the FLEXX. It's a touchscreen controller. One of the downsides to the previous generation of the or the generation we have now of the MultiPRO service tool is the USB port. They went to a stronger USB port. All in all, they did a great job building that tool. But I think that tool was originally developed for GMV, and then they added into it being able to do FLEXX as well in the RS-45 and everything by the time they were building it. So,
Gotcha.
but it's two different engineering teams. One does the FLEXX, one does the GMV, and the way that tool displays service information for GMV is far outweighs what it was doing for FLEXX. So I asked for some improvements. That's what we're waiting on. That's the delay in getting them in.
But it seems like you might have got heated a little bit about that, which brings me to our next segment. Is stay heated or chill out? Greg, seems like something you got, you know, that you're pretty heated about.
I am pretty heated. I'm pretty heated about multi-zone and multi-pro systems. I would just try to get the message out there that we need to be more careful about sizing indoor units, and we need to be quit oversizing them. You need to size them to the load of that room. When you're talking a multi-zone unit that has multiple indoor units, you know, if you're sizing ahead for one room or two rooms, or a ducted unit or whatever, it doesn't matter. it has to be sized for those rooms. You're not sizing the system for a whole home. You're sizing the system for the whole home for the outdoor unit, but them individual units need to be sized properly to those indoor units. And if you don't, you're going to have operation problems. And we get complaints more than I like to see. And JD, you can attest to this as well, about overshooting or overcooling or overheating the space. And they just know it's a GREE problem. When
Oh,
we
yeah.
dig hard into it, it's because the unit's oversized for the space and minimum runtime to the equipment. And we don't have no fix. We do have a fix. The only thing you can do at that point is to put a 24-volt adapter on there and put it on a regular thermostat and give it a hard on and hard off. And I don't know how to tell you guys this any better than just flat out say it. The best way to run an inverter-driven system is communicating. That's the most efficient way for that system to run, is communicating. And when you start giving a system like that a hard thermostat cutoff and back on, it doesn't affect the efficiency as bad as you would think, but it's still affecting the unit. It's not what it was really designed to do.
Right. I mean, you're paying money to limit it.
You're paying money to limit. That's a great way to say it.
Yeah. I mean, the really cool thermostats and stuff that we're talking about using, those are great lipstick. Well, hold on. Let me see if I can find another way to say it. It's great to take a super communicating thermostat that does all the cool things and all that kind of stuff, and then apply that to a regular style system. I mean, that can absolutely improve the operation of a regular style system. But that, as good as that thermostat is, you are just, I mean, it's trying to make the system dumber. I mean, that's really all it boils down to. And so that's a fix. It's a fix. It's a Band-Aid. It absolutely is. But we can see this in the sales data. The amount of 1-ton units, everybody just goes 1 ton, 1 ton, 1 ton, until you, I don't know, run out of 1 tons, and all of a sudden a 9,000 BTU is fine for all applications. I mean, I'll give you an example. Our one-way sealing cassettes are offered on MultiPRO, are offered in 7, 9, and 12,000 BTUs. We sold all of our 12,000 BTUs first. We had some shortages, with the tariffs and all that, but we sold all of our 12s first, and then we sold all of our 9s, and then we sold all of our 7s. How many load calculations do you think were done in that in that purchase?
Well, and I also
Handful,
want to point
maybe.
out, guys, this is not the first time I've brought this up. This has
No.
been over in multiple trainings over and over and over again, that we need to express that, and I preach it to the choir. If you've got your smallest indoor option, if you're wanting to do a wall mount, like James said, it's 7K, and that's the smallest option you have, and you're only doing a 150 square foot room, that's probably still too big, depending on your design layout and everything else. So then at that point, so let's say you got a couple bedrooms or something, or 2 small offices or something, you might be better off at that point to use a ducted unit and do those 2 spaces with a ducted unit to do 2 zones at like a 9K ducted. Right? Or, for example, maybe we go all the way down to 5K in cassettes, right? So maybe a 5K cassette would be the better option for that. Each room you get a 5K cassette instead of a 7K wall mount. I'm just trying to get guys to be more mindful of it, because we get them complaints and they're like, there's something wrong with this unit. It keeps overshooting, it keeps overheating. And then you get all into it. The bottom line comes down to is it's oversized.
Yeah.
James and I were talking about this the other day. If the lowest BTU rate of that in cooling was, say, 3,000 BTUs, and I don't know if that number is correct or not, and your highest is 7,000, and that room is only requiring 3,000.
Right. Right. Well, that's, that problem exists as well on single zone. I mean, I believe we've got a submittal that we can pull up for just a 4L IV12. I just grabbed just a random one to pick. But if we get the data up there, it will, I mean, we can see the minimum capacity is 2,388, right? Well, in order to protect itself, it also has to have a minimum amount of run time, right? Because there's a certain amount of oil that we need to get back to the compressor. We can't run at a super minimum and then just shut off, and then run at a minimum and shut off, and so on and so forth, right? You scroll down to the second page there and zoom in on the that top line. Well, I guess that's the wrong one. Anyway, I don't know what's happened here. That's probably just for the multi-zone application, maybe. I'm not sure. But yeah, that's just for the wall mount. But anyway, for the system, the 12,000 BTU, it's 2388 to 13307. So the minimum amount of capacity that it can provide is 2,388 BTUs. All right. How long? Here's a test question for you guys. How long is the minimum run time on the system? Typically 6 minutes. It is for multi-zones, and it definitely is for multi-pro. 6 minutes, the typical minimum run time. So if I come on and I call for cooling, and I have to run at 2,388 BTUs, or in the case of this 18 that we're displaying right now, or that we can display, let's do that. We got an 18,000 BTU unit, 3753 is the minimum amount. And if I've got to run for 6 minutes, that's the minimum amount of capacity that I'm going to provide. If your space can be cooled down, providing only 3,753 BTUs and only running for 6 minutes at a time, it's too large. It's too big. Does it make sense? I mean, I think that's pretty evident. At that point, yes, it's too large. You know, the thing is, if I took a 1.5 ton regular system and I put it in the same situation, oh, you'd be, your walls would be dripping. You would never be able to remove the humidity in that, in that space. So when people say that you can't oversize inverter driven systems, what you should be saying is must not oversize inverter driven systems. You absolutely can oversize them. It's just that, you can get away with a lot more than what you would out of a regular system. But we see it, it's not that we see it a lot, because we do sell a lot of these units. but when it does happen, it's trying to convince, and nobody likes to be asked for their heat load calculation because, well, they probably didn't do it, and there's a reason why, still to this day, our 1 ton units, no matter what application it's being used in, is the most common unit that we can sell. I mean, that's what people keep buying. I can take you back 15 or more years ago when I worked for a different manufacturer. One of the most common sizes that we did sell was the 18,000. I'm going to go out on a limb here and say, well, that's what everybody went with, was because it was 1.5 tons. That's what they knew. 1.5 tons was the smallest unit you could get, right? If I wanted to go buy a Goodman or a Train or something like that, unitary system, 1.5 tons was the smallest size, right?
Right.
So anyway, I think that's what people were used to, and now they've adjusted to 1 ton. But I think a lot of the applications that you're looking at could easily get away with a 9, or in multi-zone or multi-pro applications, a 7 or a 6 or a 5. And if it's got to be smaller than that, use a ducted unit and branch off, like a small ducted unit, branch off and provide even less capacity. Because remember, we're sizing all this. All this data is based on 95 degrees in cooling, So if it's not 95, you get what I'm saying? I think that makes sense. I think everybody, agrees with me on here anyway. But we'll see in the questions and comments whether or not everybody agrees. But you were supposed to vote for stay heated or chill out, and I forgot to mention that on Greg's conversation there. Just go ahead and throw in there on the on your question mark icon to the right of the screen whether or not Greg should stay heated as to the oversizing of our units, or he should chill out and just get over the fact that people are going to oversize them and then complain about them.
Well, I think, James, we you're right. It's not an overwhelming problem, but trying to convince the people that have done it that that is their problem is
Yeah,
difficult. And
right.
also, I think there's some of them, some out there, they're wiser than I wanted to give them credit for. And the reason why we haven't heard about it is because they've already put 24-volt adapters on it and fixed it
Right.
themselves.
Right. Well, I mean, I can give one example. I know that we got a heat load calculation one time that was on a second story, and the heat load calculation showed that the floor was losing heat, like it was a single story. Well, obviously, that's not how second stories work, is it? You know, that's a heat gain typically, right? Which was enough to throw it off right there. And then, yeah, we had 1-ton units and 110 square foot rooms, you know, that kind of thing. And the complaints were the complaints. Oh, it's overshooting. It's not accurate. It's not this. It's not that. You know, you probably have an argument if that was the one unit that we sold that year, you
Right.
know, but we sell a lot of them. I mean, I've got them in my house. You know, I know one of them's oversized. I'm not saying I did it right. I'm just saying I got it in my house. Um, but anyway, again, vote, stay heated or chill out, and we'll move on. We'll take a look at one of our YouTube comments, or we can take a break real quick and look at the questions that have come in. Do we have any questions that have come in?
Yeah, we have quite a few. We have a comment
Uh-oh.
here from Troy Rudd. He
Uh-oh.
says, "Stay heated!" Exclamation mark! Exclamation mark! Exclamation mark!
Gotcha. All right. Yeah. So far we've got 2 votes for stay heated. I mean, I think that's good enough, right? Well, as far as stay heated and chill out, I'm going to say stay heated because I mean you and I were discussing it, so you know I'm kind of biased that regard. What about you, Jesus? Stay heated or chill out?
Oh, chill out, Greg, man. I'm tired of hearing you y'all mad.
You know what?
No, I'm just joking. Yeah, but seriously, like just to sum it up, like you don't want to put in an inverter driven system and dumb it down. You don't want to do it. Don't do it. Just size properly and that way you avoid all the callbacks and all the frustration. So yeah, definitely stay heated.
Right.
How
Gotcha.
about you, JD?
JD.
I say stay heated too, Greg.
All right. 100%. Stay heated. Okay. So we'll come back to that and see what the tally ends up looking like.
So it looks like we got about 5 questions. I don't know if y'all want to get into those
Keep
or
going. Yep.
okay. So
Yeah, let's go.
Todd commented. He said on the Daikin Fit, I can set the balance point and also a heat pump lockout temperature, and they can be different. It would solve the homeowner running the stat up at mild temps. This is why I was wondering.
So a balance point and a heat pump lockout temp.
Hmm.
Hmm.
So
Well, James, I don't know, especially with their MultiPRO Ultra, that we really need a lockout temperature. Those
Well,
things are rated all the way down to minus 20.
22, minus 22. Don't
Thank you.
take that 2
Thank
degrees
you.
away from that.
yeah, give it that 2 degrees.
Yeah, well,
And they're still highly efficient at minus 22 degrees.
yeah, there's a lot to talk about on that. Yeah, I mean, if we take something that bottoms out at -4, I don't know what the Daikin Fit's doing. I don't, I don't
Right.
try to keep up with what everybody else is doing. No, obviously we do, but I don't know what it is off the top of my head. But if you take a look at the capacity charts that they likely have on their website, like on their engineering data manuals, it's exactly what they call them, by the way. If you take a look at those, take a look at the capacities that you're outputting at specific temperatures, and then also look at the coefficient of performance at those temperatures. Like that's the amount of watts in versus BTUs out, or watts in versus watts out. Take a look at those, see what you're getting. You know, at the point at which you're like below 1, it's less efficient than electric heat. Most of these equipment, it is, Daikin, Mitsubishi, LG, or anybody, it's going to be more efficient than electric heat at most of their published temperatures, right?
Right.
But throwing a wrench into that conversation, if you've got a cold climate heat pump, typically, I mean, taking a look at our data, you can be twice as efficient, 2.5 times as efficient, depending on which capacity unit you're looking at. at even minus 22. And then of course it climbs from there. You know, you might be at 3.5, you know, at your design temperature. So at that point, you definitely have an argument. At that point, you definitely have an argument on what would actually be cheaper in that regard. You know, like you got to look at BTUs per therm and how much that charges, and then how much that might vary depending on what the gas company's charging versus what the electricity company's charging. I mean, there's a lot to talk about there. One of the things that I know that we've mentioned before is that when we've had people convert from gas to heat pump, it's just mentally they look at gas as being their heating bill, and they look at electricity as everything else. They eliminate their gas furnace and go, my electricity bill went up. Well, of course it did. Of course it did. I mean, what I've said in the past is if you had a gas-powered TV and you know, appliances and your lights and everything else, you would probably look at it a little bit differently, right? But you know, like I said, it all depends. I mean, I like having, you know, the consumer to have those options. But at the same time, if you're the guy setting it up and you walk away, gas could have been cheaper that day. Gas may not be cheaper the next day. You know, I mean, one thing I can say about electricity rates in Texas, a lot of our electricity is generated by natural gas. So when natural gas goes down, electricity also goes down. If you don't have, I mean, if you've got a variable rate. So
I mean, but realistically, James, it all comes down to a lot of things when you're talking with gas furnace. You got to consider the efficiency of the gas furnace, what fuel they're using, whether they're using propane or natural gas. You know, it is 80%, 92%, 95%, 97%. I mean, and then the other thing I will say is, and I can't speak for the Daikin Fit system either, but in our systems, whether it's FLEXX or MultiPRO, once you go to a dual fuel setup, it's no longer a communicating system. You're using a 24-volt control because your furnace is 24-volt. And we're adapting that into either a 24-volt unit that can be 24-volt, which is the FLEXX, or with MultiPRO, we're using an interface that allows the 24 volts to signal into the communication to tell the heat pump when to run and not run, stuff like that, right? So at that point, now you have the ability or the option to use whatever thermostat you want that has those lockouts that you're looking for.
Right. Right. Well, I mean, there's a ton to talk about on it. I mean, I just personally, I did have a calculator there for a while that, you know, we could probably update and maybe publish as far as being able to plug in your, you know, BTUs per therm and all that. I honestly think that they continue to make it very difficult to figure out what would be more cost effective.
They do.
I mean, I can't imagine why they would do that. But I mean, it can absolutely just depend on where you live, what expected temperatures are, what the design temperatures are, all of that. But yeah, I mean, we can always take a look at adding that as well, you know, from a balance point versus lockout temperature.
I got another comment, then we can get to some more questions, but I'm a little bit more heated now because I didn't get 100% stay heated. I only got 96%.
You know, I'm gonna go look and see who's, you know, said chill out. I'm joking.
Jesus, let's get to the rest of the questions.
All right, so Robert, not sure if I asked this already. He said, does the FXE FXU indoor blower speed vary as compressor speed varies in RS-485 mode? So
it does look at the inlet and outlet temperatures, and it does modulate the blower speed based on the indoor coil temperature. And when the fan's on auto, and MultiPRO basically does the same thing. So it's going to adjust under load demand because your inlet and outlet temperatures are going to adjust with load demand and the speed of the compressor, right?
Yeah. So also based on the difference between your set point and your temperature.
Correct.
So as far as the speeding up and slowing down of the blower, it's effectively indistinguishable from wall mount units and how they operate. They speed up and slow down that blower speed and provide more or less capacity and change their latent versus sensible load characteristics or curves or what. I'm not an engineer. But it absolutely will dehumidify better in that regard. So yes, it does speed up and slow down the blower. It does give you a variable blower. at that
But
point.
realistically, if the machine is doing what we want it to do, which is maintaining temperature, majority of the time it's going to be a lower speed because of the fact that it's maintaining. We're not getting into high revs once we get the load under control. Now, when you get in the wintertime, though, temperatures, that's where I see my MultiPRO system really starting to rev up a lot, because now we're trying to absorb heat outside and release it inside, which traditionally is more difficult than taking heat out of a hot house and dumping it outside, right?
Right.
All right, so moving on here, we got the next question. Probably more a comment. So Jeff was asking, new R32A coil, only for 1-to-1 flex or option to use with mole R32 multi with wall evaps. So you guys kind of
Run that question one more time, please.
okay. So
Oh,
new
okay.
R32A coil, only for 1-to-1 flex or option to use with mole R32 multi with wall evaps.
Can you use the
A coil with the
A
I
coil
don't
with the
think the
multi-zone?
A coil can be used with the multi-zone. JD?
Not that I know of. No.
I don't
No,
think so.
it's no, it can't.
Basically, we're gonna have a flex coil or flex with R32, and then right after that, they'll be releasing the MultiPRO coil as well for dual fuel.
Right. So in that regard, if you want to use an A coil with a gas furnace, but also use wall mount units or whatever other units you want to do, absolutely will be an option for MultiPRO, just as it was with R410A. But on the multi-zone right now, no, there's no plans for a dual fuel A coil for multi-zone.
All right. Looks like Jeff doing another comment in there. He said 4 LIV9 and 12K R410A 1-to-1 ramped down to 3K. New LIV R32 not near 3K. So
What size?
it's a 9,000 BTU.
I think that there was some problems in the submittals,
Yeah.
and they were getting those redone. JD, you know if they've been fixed yet or not?
I have not heard any update.
I'm pretty sure they haven't been updated yet. They're coming.
Mm-mm.
The min maxes on the R32 single zone mini splits was incorrect. Some of that information was incorrect, and they're redoing them and getting them republished.
Gotcha. Well, I just
The
pulled up.
numbers should come up different.
Yeah, I pulled up the Levo 09 R32 just now on the website at greecomfort.com. Let's see. I had it up and then I lost it again. So Levo 09 HP 230 V1I or V1R 32 AO is 2388 min and 10,300 max is what it says now. The one I just pulled up anyway.
Okay, then that's been well. Look at an 18, will you please? That's
Yeah.
the one that's one of the ones I caught.
All right, I'll open a 12 and an 18. How about that? 18, 3753. So it's definitely lower.
What's max?
And max is 13307.
Then it's been fixed.
No, hold on. No, max is 19960. 19960.
It's
So
been
yeah,
fixed. It's been
right.
fixed. So I don't know if when he looked at those documents. So what did he say? What did he say in the question was? Let's look at the one. Which one he said?
He's saying that the 9 and 12 for R410A 1-to-1 it did ramp down to 3,000. The new LIV R32 not near 3,000, but it is according to the submittal. So we updated those.
Okay, so the submittal's been updated. Okay.
Yeah.
So that answers the question. So he must have looked at it before we got him updated.
Yeah.
All right. Well, looks like Craig was asking, can you help me size an attic renovation?
Craig with who?
Craig with Baker.
Yeah. We typically don't do sizing. We leave that up to the contractor to make sure that they do a proper heat load calculation, the size of the equipment.
Right. Now, as far as assisting, once we have that capacity, that required capacity, we can talk about what we might do, like where we might set units, that kind of thing. So, I mean, we can assist in that, but yeah, as far as calculating, no, I mean, you give me the R values of the walls and stuff. No, no, we don't typically do that. Generally speaking, you want to be the ones with the eyes on the job, to go in and verifying those things instead of, a bunch of assumptions. But yeah, anyway, any more that we need to
That
talk
is,
about?
I believe that is it.
Yeah, so on the stay heated, chill out, did we already take a look at the vote tally on that?
Yeah, it was 96% heated, 4% chill out.
98 to 2?
98. All right, that's close enough to 100%. I'm happy now.
Yeah. Right. I don't see any chill outs. Maybe I'm wrong. All right. Moving
because
on.
that still falls into that same old saying that we've said for years and years in HVAC. Bigger is not always better.
Never. Not even a split system. Regular split.
All right. Well, I tell you what, we're running at 100 minutes now, an hour and 40 minutes. We've got some. Yeah. We can go through a couple YouTube comments, that kind of thing. But
I'm game if you're game.
all right, let's take a look at a couple YouTube comments. So the first comment that we'll look at is how inverter-driven compressors work. There are a lot of questions and comments on that. I think mostly because Greg's the one doing it, and he just seems to attract questions. A lot of confused looks, but let's see here. We get one of the great things, kind of off the subject here, is that we get questions and comments from all over the world. It seems like a lot of people go to YouTube and look at our videos and then try to figure out what they got and what they're not getting at GREE, Chechnya or something. But anyway, the gentleman says, thanks, perfect explanation with simulation video. About the DC bus voltage, how can it be higher than the supply input voltage? That's a good question.
Great question.
Simply capacitors.
No,
I was gonna say magic.
Don't say magic. We haven't passed out magic wands yet. But
those big
yeah.
capacitors that are on there.
Yeah, those big fat capacitors that are on there, they help to step up that voltage and maintain that higher voltage, and helping to reduce our amp draw. There's another question on that, and we knew when we were going through the explanation. It's an explanation of how things work as we understand it, not necessarily from a engineering standpoint, electrical type standpoint. It's good to know a basic explanation of how it works. But a gentleman said, so converting single to three-phase in essence, why not just use a VFD? Are these, quote, inverters just cheap versions of VFDs? I can see where the sine wave would be more stable, a more stable voltage as well. All right, so anybody want to take a whack at what the difference between a VFD and an inverter is?
Well, an inverter driver versus a VFD, the whole machine is taking a whole lot more inputs and calculating all that into the actual speed of the compressor.
Right.
So whether the main board's built into the drive board or you got a separate drive board doesn't really matter. But part of the reason why we use the drivers that we use is because of all the other input the machine is getting. And I've talked about that in another video of how inverters work, meaning all the data that the board is looking at to know what speed that compressor should be running at.
Right.
So it's a lot more in depth than what a VFD.
Yes, typically. Absolutely. Now, if I take a VFD and I take all those inputs and all that, and I could adjust the speed of what the output of the VFD is, what's the difference? There's not one. It's the same thing. A VFD is an inverter driver. Exactly. I will say that, judging by the construction of some of the VFDs that we're talking about, one of the things that they seem to often lack is noise filters. So if you've ever had, electrical or audible noise coming from a VFD, it would be because they do not have noise filters. I can't say that all of them are that way, but they absolutely can be. But a lot of the differences really between these can be a sawtooth sine wave VFD or inverter board versus a true sine wave inverter board. Ours are true sine wave. So like if you buy a converter or an inverter or whatever for your vehicle, and you've got an option between true sine wave and then not true sine wave, depending on what you're operating, it could be better to have a true sine wave. If you want to provide power to your house, for example, you want a true sine wave inverter. You don't want something running on MOSFETs or whatever. I don't know that anybody continues to use the MOSFETs with the sawtooth sine wave. If there are, I hope they don't charge a lot, because that's it's the least expensive way to convert. But anyway, a lot of great questions come from that kind of thing. But as far as like ECMs, VFDs, inverters, and all that, they're all pretty much just doing the same thing.
They're very similar. Yep.
If I take the inverter and I put it in a metal housing and give you a push button on the front of it, that's a VFD. Yep. Anyway, the next one would be got JD in a video, multi-zone troubleshooting. All right. And here we are, a gentleman's talking about I'm an engineer who fixed recurring E6 errors on my GREE system after licensed techs failed to resolve it. Well, that seems combative. The issue was buried low voltage comm wires. I replaced them with above ground conduit and it's worked for over 2 years. Even with continuity, buried wires aren't reliable. Most E6 errors likely stem from voltage issues. GREE should consider prohibiting underground comm wire runs. Well, I don't know where it would be common to run our communication wires underground. It could be, this could be global, right? Could be from some other place. I mean, first off, with the communication wires, if you're using SO cable, usually not buried, what do you call it? Burial rated anyway.
Right.
So, you're not supposed to do that anyway. As far as like how that's ran, we give our 14.4, we give stranded, we give shielded, maybe, that kind of thing. That's usually the recommendations that we give. How it goes into the building or whatever, we don't really provide much in the way of recommendations. But chances are, I'm going to go out on a limb and say that if they had used shielded, if that's what was part of the issue with the communication, if they had used shielded and grounded that shielding at the outdoor unit only, it might have been able to bury that cable and use that cable as is. Anything you guys like to add on that?
Yeah,
Well,
James actually. Go ahead, Greg.
Go ahead, Jay. Jesus.
No, I was just saying, I actually just had a call last week or the week before having the same type of error, E6 error code, and everything was buried underground. We checked out all the components and everything. Everything checked out as fine, and it would run for, less. I mean, it would run for about 8 hours and then throw an E6 error code. And, I started asking the technician, how is your communication ran? And he said, oh, it's all buried underground with the line sets. I said, really? All right, well, go ahead and run a temporary wire from your indoor unit all the way back out to your outdoor unit. Just do it through the driveway, obviously, where no one's going to trip. And he did that. And yeah, it definitely fixed the issue. And he called me and he was like, dude, it's still running, there's nothing wrong with it. So there was something, either, the conduit was full of water or whatever the case was, but definitely something going on in the ground inside the conduit where the communication wire was running. So
Probably some moisture.
yeah, more than likely. So
what I was going to say was, I know I've dealt with this with different manufacturers over my years, and burying line sets in the ground, any of that kind of electric in the ground, when it comes to HVAC, there's a lot of code requirements, a lot of manufacturer requirements that line set be in a conduit completely sealed, guaranteeing there's no moisture getting in there. because all of that plays a role in your refrigerant too. If your insulation on your line sets and everything's getting soaking wet, the insulation is no longer pliable. It's not doing anything because it's sopping wet. And then if you're getting moisture into your cable, whether it's for a multi-zone mini split, that's high voltage comms. That's not low voltage comms. And I believe the comment in there was about it being a low voltage comm wire. Well, it's not. It's high voltage. And it absolutely should be in sealed conduit if they're running that wire underground. If they just direct buried that, all bets are off. The cable ain't even ready to be direct buried.
Right.
Yeah. Well, I mean, a lot of it's not UV resistant. A lot of it's not even what you're supposed to be using to begin with. There's a lot of different, makers out there. We don't sell wire, but there's a lot of different makers out there that sell all kinds of things that would work really great. That have like built-in conduit and UV resistance and shielding and all kinds of things just built in. But it's also more expensive than SO cable. And if you don't know, SO cable is really, really similar to like extension cord. It's from a
Well, I believe it's even got a paper wrap up in it, so if that gets wet.
yeah. I don't know how you dry it out after it gets wet.
You're not.
You're not. No.
You're not. You just blow air through it really hard.
I had an electrician friend of mine tell me one time, he goes, I was talking about running some electric, putting in the ground and conduit and everything. And he's like, just use UF wire. He goes, I don't care if you put it in conduit or not. That water's getting in there.
Yeah.
Yeah.
Well, I just want to take a moment real quick. I want to, it's an hour and 51 minutes into this episode, and but we still have a lot of people on. Just want to, thank just a handful on there. I'm not going to include everybody, but Yusuf, Willie, Troy, Hi-Ho, Robert, Kenneth, Karen, Joe, Jeff, Glenn, Gary. I mean, there's a whole lot of people still on. So if you're still watching and you're listening, I want to give you a special shout out. I mean, this is like an episode directed by Martin Scorsese at this point. One of the longest episodes we've ever had. But I'm going to go ahead and cut it off right there. So just a few things real quick. We've got a training season. It starts September 10th and 11th, as we mentioned earlier. We've got on the 10th, we've got R32 units and setup, controls, install, and troubleshooting. And then on September 11th, both at 11 a.m. Eastern, MultiPRO R32 updates, alarms, and components. Be sure to check that out. Those are two very, very important product categories for us and you. Do not forget that we have the Contractor Pro service app available from your smartphone at greepros.com. Give you tons of great information, gives you easy access to that as long as you have cell phone service. You've got access to that. And last but not least, remember, agree?
We're by your side.
By your side.
We're by your side.
Please like or subscribe to our channel at GREE Comfort on YouTube and head over to greecomfort.com/training for more tips and tricks and all the information you need to help you out in the field. And that was a good show.